Okay, now we have a sample problem on the board involving a circuit that is, of course, this is a series circuit. How do you know it's a series circuit? Because of they are connected what? Side by side. And the emphasis is on the current flows from here to this point. So you're seeing the current at this point is equal to the current at this point is also equal to the current at this point. But the voltage are different. So now you can look from the question, they say what? Calculate the current. They didn't specify the current in each resistors because they know that the current is what? Equal at the full circuit. But now look at the C part of this question. Calculate what? The PD across each resistors. That's to tell you that the voltage across each resistor are what? Different. So now you say calculate A, the equivalent resistor, B, current, C, PD across each resistor, D, the power or the total power. Of course, there is a power at this first resistor R1, there is a power at this second resistor, and there is a power at this third resistor. You can do that by calculating the individual resistors and summing them, or you follow this total voltage to do that. I will show you in the video. So now let's continue. So first of all, we are to assign here R1, we are to assign here R2, we are to assign here what? R3. And now the voltage across here will be what? V1, the voltage across here will be what? V2, the voltage across here will be what? V3. So that's how you start by assigning it. So you have to start by writing the given parameters. So we have solution. So what I'm going to do is I'm going to divide this body into two so we can minimize space. So we are giving the given parameters. So what are we giving? So number one, we are giving the first resistance, which is R1. So we have here as what? R1 is equal to what? 330 ohms. We have R2 to be what? 1.5 kilo ohms, which is the same thing as 1500 ohms. So we can call this what? 1500 ohms. R3 is what? 470 ohms. So now, what is the formula for what? A series connection for the equivalent resistor. So for us to find this, we have A, we're looking for what? The RO equivalent. RO equivalent. So we said that from series connection, the ROT, which is the total resistance, is equal to what? RO1 plus RO2 plus RO3. Why am I stopping at RO3? Because there are 3 what? Resistors. So therefore, we're going to do that by summing all of them. So we have ROT. The first resistor is what? 330 plus the second is 1500 plus the fourth is what? 470. Now, when we sum this, what do we have? We have ROT is equal to what? 2300 ohms. Is that the right answer? 2300 ohms. So the total equivalent resistance in this circuit is what? 2300 ohms. You can express it as what? 2.3 kilo ohms, because we said that kilo is what? 10 raised to power 3. So therefore, this is the value for the A part of this question. Okay, now let's solve for the B, which is the current. Okay, now so for us to find the current in this circuit, we are going to play with what? The total voltage and the total resistance. Now, the B part, which we are going to look for what? The current. So the current in this circuit, from Ohm's law, we say that V is equal to what? IR. For a case where we are dealing with the total parameters of this circuit, we are going to have V subscript T and what? R subscript T. So the total current, which is IT, is equal to what? VT over ROT. So we are having the current to be what? IT is equal to what? The total voltage is what? 24. So we're having 24 over what? 2300. So please, what's the answer? Please point it and give me the answer. So we have 0.0104, right? Ampere, because the value for current is ampere. So this is the value for the current in this circuit. Now let's go for the C part. So we have the PD each resistor across resistors. So how do we calculate the PD across resistors? PD is also known as terminal voltage or voltage. Now, let me explain what PD is. From our videos when we are defining the basic terminologies of electrical technology, we say that PD between 2 points is what? The work done required to move one coulomb of charge from one point to another. It is that PD we are talking of, please. The terminal voltage. Let me just bring your knowledge back to it. Because of it's very important that we understand, because we are working with the principles of what we know. So try to get everything we know. Everything we have learned is deep. We're going to use it in the future. So that's why we start the course from basic unit. The PD across each of those resistors. We'll say for V1, which is the PD for the voltage at the first resistor, which is R1. So we have I1, which now take note, there's nothing like I1 because we say that the current is what? Equal at exactly. So now we have I total, you are still using that I total multiplied by what? R1. So when you do that, the current is what? 0.0104. R1 is what? 330. So we have multiplied by 330. Please punch this and tell me what we have. So V1 is equal to what? 0.0104. 3.32 volts. Now for V2 is equal to what? ITRO2, which is equal to what? 0.01404 multiplied by what? 1500. So when you punch this, what will they have? So we have 15.00 volts. Okay, now what will be the value for the V3? V3 is equal to what? ITRO3 is equal to what? 0.0104 multiplied by 470. So we have 470 ohms. So V3 is equal to what? 4.88 volts. Okay, now these are the voltage across each resistors. Now, if you have to investigate the law, which will state that the voltage across this point is equal to the sum of all these things. So now let's do a quick test. Please punch 3.432 plus 15 plus 4.88 volts. It must give you a number known as 24, which is the total voltage. Punch it and you see that it will give you 24 volts. I'm waiting for you while you investigate that. So punch that. What do you have? 23.8 something. Of course, it's approximately. This is due to what? Approximation. So this is how we get it. We have gotten the C, which is the PD across each resistors. So now we have to look for what? The total power. So that's the last part of this question. So you can see that the space is finished. We are going to do it somewhere here because we don't want to clean the board. So we have the total power. So we're going to do it here. The D part is total power. Total power. Now, there's a concept to this. You can also do it. There are two ways to calculate this total power. You can calculate, of course, we know that power is given by a current, total current multiplied by what? The total voltage. Okay, this is one way to do it. The total current multiplied by the total voltage. So we have that P is equal to what? 0.0104 multiplied by 24. Please give me your value. What do you have as your power? Okay, now why the answer is coming? The second concept to do this is by calculating the power at this resistor, calculating the power at this resistor, calculating the power at this resistor, then sum all of them. Okay, now so let's do this one first. 0.2496 watts. So therefore, this is the value for the power. So while we have that, let's play with the second method to calculate this power. Let's play with the second method to calculate this power. Okay, now the second method for this power is to calculate the power at resistor 1. So let's say for resistor 1, what will be the value of the power? So now power for resistor 1 is what? P1 is equal to what? I multiplied by what? V1. Take note, for this we use V total because we are dealing with what? Calculating the total power in this case. The total power can be gotten by summing the individual powers because we have in 3 resistors there are 3 powers. Is that understanding? So now point your value 0.0104 multiplied by V1. V1 is what? 3.432. Punch it. So your total power for V1 is what? 0.0356. You have what? 0.0356 what? 928. Let's call it 928. 928. Let's leave it like that. So we have watt for the first one. So we have for R2, what will be the value of what? The power. So we have IT multiplied by V2. So point that 0.0104 multiplied by V2. V2 is what? 15. So point what will that value give us? We are waiting for him. 0.156 watts. Yes, so for the third resistor, which is P3, is equal to what? IT multiplied by what? V3. So now point 0.0104 multiplied by V3. V3 is what? 4.88 volts. Point it, let's see what we have. Let's wait for him. Zero point zero one zero four multiplied by 4.88. 0.0552. Now, please point all these values, sum all these values. Sum 0.03569. Let's approximate this, please. So let's leave it to, okay, let's call this 7. So this is the 7 watt. So do 0.035. Please do not approximate this because of it. See, most of the errors we have in calculations is due to approximation. I'm just doing this because of I want to so that we can just point it easily. So we're having 0.0357 plus 0.156 plus 0.05072. Punch it. What do we have? Okay, now take note. We had the total power, which is summation of all this power, which is P1 plus P2 plus P3. We had it to be what? Call it 0.2452. Now take note. We had this is in watt, of course. We had the answer, which is 0.242452. But we did that by calculating this, which is the shortcut 0.2496. So are you seeing that We can get now take note, this error is due to what? Our approximations. Of course, the error is due to approximation. But the point is, you can get this by what? Taking the total current and what? The total voltage to get this thing, and we got 0.2496. Those things are, they are, of course, they are the same. Those are due to approximation. We're not having the same answer. But we can do that. The alternative method, which is the longer cut, to make your work more understandable, is to do what? Calculate the power at R1, calculate the power at R2, calculate the power at what? R3. Sum all of that, you're going to have the same answers. If you do not approximate, or you approximate with good, and if you approximate very good, you're going to have the same answer. So the concept is easy. We calculated what? The equivalent resistors. We had this to be 2.3 kilo ohms. The second one was what? The current. We did that by what? Introducing what? The total voltage is equals to what? The total current multiplied by what? The total resistance. When we substituted that, we had that the current was what? 0.0104 amperes. We have been using that value to calculate everything, because we know that for what? A series connection, the current is what? The same. So that's the concept we use to what? Calculate the PD across the resistors. We use the what? The total current to do that. We had this value. Now to check, we summed all this value and it gave us an answer close to 24. That's to show that we are correct. Now what we did next is what? To calculate the total power. There are two methods to do that. It is what? To do it with the shorter cut, which is the power is equal to the total current multiplied by the total voltage. When you do that, you have 0.2496. This is more accepted. Of course, two of them are accepted, but due to approximation, this is more correct. Now, I showed you there's an alternative method, which is to calculate the power in each of those resistors and sum them. So the concept is easy. Let's solve questions involving circuits. Thank you very much.